When two quantities, x and y, are proportional, they can be represented by a direct variation equation, which is y equals mx. There are a few things that are always true in a direct variation equation. The first, x and y are proportional. This means that as x changes, y is going to change at a proportional rate to that. The graph of a direct variation equation is always going to pass through the origin. And as you remember, the origin is 0, 0 on our graph. And the equation can be written as y equals mx, where m is going to be your slope or your unit rate. For example, the cost y in dollars to rent x video games is represented by the equation y equals 4x. We're going to graph the equation and interpret the slope. The first way to graph a direct variation equation would be to make an xy table. Now, it's important to remember that when you're dealing with a real-world problem, you always want to understand what your x and y represent. In this situation, y is the cost in dollars and x is video games. You're not going to rent x number of video games, and you're not going to pay a negative amount of money. So when you're choosing your x values to put into your xy table, you want to choose positive numbers. We don't want to have x number of video games. So I'm going to choose 0 video games, 1 video game, and 2 video games. So x is games, and y is how much we're paying. So if I take my equation y equals 4x and I plug in each of these x values, starting with 0, you can see that 4 times 0 is 0. So when I put in 0, I get out 0. If I use the equation y equals 4x and I buy or rent 1 video game, substitute the 1 in for x, 4 times 1 is 4. If I rent 1 video game, I'm paying $4. What will I pay when I rent 2 video games? Well, 4 times 2 is $8. So if I rent 2 video games, I'm paying $8. So my 3 points that I can add to my graph are 0, 0, 1, 4, 2, 8. 0, 0, 1, 4, and unfortunately 2, 8 goes off my graph, but it would be up there somewhere. Now when I draw the line for this graph, I want to be sure that I stay in quadrant 1. This line is not going to extend into the other quadrants because that would be representing false information for this situation. I cannot rent negative video games. I cannot pay a negative amount of money. So this is not going to go in to any other quadrants than quadrant 1. The graph goes through the origin, and you can see that I find 1, 4 as my unit rate. I'm paying for each video game that I rent, I'm paying $4. The slope is 4. I can see from the graph as well as my table, that means that I'm paying $4 per video game. It's my unit rate. It's how much I'm paying for one. That is interpreting the slope, putting it into words. The slope is 4. Remember, whole numbers are always over 1, 4 over 1, which means it will cost $4 per game.
Hey everybody, it's a couple minutes before 3. I want to thank everybody for all their hard work today.
Pardon the interruption.
I saw a lot of people working, a lot of groups really active, and a lot of good conversation that came out of this morning session in particular. I hope everybody has a great weekend, and I wish you the best. Take care.
Let's do a second example. This example is going to compare two different chair lifts. Putting this over here on the left-hand side. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows the distance that a 2-person ski lift travels. Which ski lift is faster? Now, it's really difficult for me to compare these two situations because one is being represented in a graph and one is being represented as an equation. So I'm going to try to break these down so that they are represented in the same fashion. I'm going to start by taking this y equals 2.5x and adding it to my graph. That way I'll have two lines that I can compare to be able to determine which one is traveling at a faster rate. Again, to graph a direct variation equation, I'm going to start by making an XY table. We're talking about time and distance. I'm not going to have negative amounts of time, and I'm not going to have a negative amount of distance. So my choices for x values, I'm going to start with 0 seconds, 1 second, and 2 seconds. Now I'm going to take each of these x values and plug them into my equation and solve for y. Y equals 2.5 times 0. When I put in 0, 2.5 times 0 is 0, so y is 0. Y equals 2.5x. I'm rewriting the equation so I can substitute one more time. This time I'm going to put in 1 second. 2.5 times 1 is 2.5. And the third time, I'm going to substitute a 2. .5 times 2 is 5. So when I put in 2.2 for x, I get 5. Now I have 3 points that I'm going to add to this graph to the left. 0, 0, 1, 2.5, 2, 5. 0, 0, 1, 2.5, 2, 5. I'm going to go ahead and draw this line. So now I'm looking at two graphs. Clearly the one that I've just created in blue is steeper, but what does that mean? Well, in the equation, y equals 2.5x, 2.5 is my slope. That means that I'm traveling 2.5 meters per second. It's my unit rate. 2.5 meters per second. If I write an equation for this two-person chairlift, I can also compare my slopes. I can compare my unit rates. The slope of this line, if I calculate my rise over run, I'm rising 2, 4, 6, 8, and I'm running 1, 2, 3, 4. 8 over 4 can be simplified to 2 over 1. So if I write this in a direct variation equation, I have to be able to put it in y equals mx, where m is my slope. Y equals 2 over 1x. So what does this mean as a unit rate? Well, this is telling me that I am traveling 2 meters per second. If the two-person chairlift is traveling 2 meters per second, and the four-person chairlift is traveling 2.5 meters per second, which lift is traveling faster? The four-person lift. Graph the equation that represents the four-person lift in the same coordinate plane as the two-person lift. Compare the steepness of the graphs. What does it mean in the context of this problem? So we already talked about this a little bit. The fact that the blue line is steeper, my distance is increasing faster over time than this black line, which represents the two-person chairlift. More speed over time is representing a faster traveling chairlift. The steeper the line, the faster the unit rate, the faster the rate of change. It's increasing at a faster rate. So just to recap a couple of important things. Direct variation is always written in y equals mx plus b. When you're looking at an equation in y equals mx plus b, m is always going to be your slope or your unit rate. The graph of a direct variation equation must always pass through the origin. And where you find 1 on your graph is always going to be your slope. So it's going to pass through 0, 0, and where you find 1 on the x, you're always going to have your slope. And we also call that the unit rate. Oftentimes when we're talking about unit rate, you'll hear things like per day, per minute, per hour, per second. That's your unit rate. Again, you can see from this graph that I drew, 1, 2.5. That was my slope. 2.5 was my slope. I'm traveling 2.5 meters per second.